Hi, I'm Beth Wilson. I'm in the Education Division at the National Air and Space Museum. Welcome to What's New in Aerospace. Today, I am joined by Dr. Tom Prevot, who is the Director of Engineering and Aerospace Systems at Uber Elevate, and Paul Cerruzi, Emeritus Scholars at the National Air and Space Museum's Space History Department. Gentlemen, thank you so much for joining us today.
Thank you. Glad to be
Thanks
here.
for having me.
Now, if you're watching online, put your questions in the comment section and we will get to as many of them as we can. We will, if you tell us where you're watching from, we can also give you a shout out. To get started today, Tom, can you give us a quick overview of Uber Elevate?
Sure. So Uber Elevate is a new initiative for us. Our vision is to weave everyday flight of people and things into the Uber platform. And in just a few years from now, we intend to launch Uber Air, which is going to be a new means of transportation, of getting in around cities and between nearby cities to airports with electric aircraft. You can basically select it just through the Uber app, like other Uber products. When you select Uber Air, depending on where you are, car may come and take you to the next skyport where you will board one of these electric aircraft that takes off vertically and then very quickly transitions to winged flight, like a regular aircraft flying very precisely to a destination skyport, where it lands again vertically like a helicopter. You will deboard the plane, go into the next means of your transportation, which could be another car, scooter, bike, public transportation, whatever your preferred means is. And hopefully you will have saved a lot of time versus taking the trip on a very congested road.
And a lot of this is going to rely, I am assuming, on GPS. So Paul, can you tell us, first of all, what is GPS, and then give us a little history of it?
Well, sure. GPS is an acronym for the Global Positioning System. It's a suite of 24 satellites in a medium Earth orbit, constantly circling the globe. On board, these satellites are very accurate atomic clocks, which give you a very precise location and time information. And obviously, an application like Uber Elevate requires very precise positioning, which GPS will give you. It has an interesting history. It goes back to the 1970s when the U.S. Defense Department looked at the various navigation and positioning techniques used by the Army, Air Force, and Navy. Each one was specialized for those applications, but they were kind of butting up against each other. And the Pentagon said, let's unify this into a single system. And out of that came the design, the idea of having satellites in orbit with atomic clocks to provide global coverage, air, land, and sea, very precise. I also want to mention that the satellites, the system was always intended to be used for civilian applications as well. And we see this here today, very obviously. Many of you have this system in your cars, for example. They recognized that this service had a lot of use for commercial aircraft, railroads, trucking, container ships, and things like that. Obviously, they didn't anticipate the kind of crazy innovations in microelectronics that we are seeing the past 10 years. And I don't know if anybody really saw that coming so fast, but the system designed in the 1970s was so robust and so well designed that it's managed to handle some of these applications that we now see today, where you can manage the traveling of these aircraft, for example, in a very dense urban environment and do it safely.
We've got a lot of people already watching. So we're going to shout out to Philadelphia, Pennsylvania, Beret, Kentucky, Goodrich, Michigan, Space St. Croix in Houston, Hudson, Wisconsin, Belmore, New Jersey, and Surprise, Arizona. So we've got a lot of people watching. Please keep those questions coming. Put them in the comment section. Now, we got this question quite a bit. yesterday. And Tom, we'll start with you on this one. Can you address how the FAA will be handling this increased air traffic?
That's a very good question. So we are actually working very closely with NASA and the FAA on coming up with concepts and procedures to integrate these new set of aircraft and this new mode of transportation into the existing air traffic and also into the communities safely, so we can conduct this safely. There are a number of safety layers that exist in the current system. Obviously, the commercial air carriers conduct kind of the most safe operations that are out there right now. And the reason is that there's many safety layers in place, starting from the aircraft that have to be certified, operators have to have safety management systems, pilots have to be well trained, and we've got an air traffic control system with well experienced air traffic controllers keeping aircraft safe. So the FAA will keep a lot of those safety layers in place, but we're working on some innovative means of addressing some of the bottlenecks that exist in the current system.
Paul, can you talk a little bit about how the FAA uses GPS and other methods to move traffic around currently?
Well, prior to the implementation of GPS, there were a number of systems, many of which are still in use, of localized radar and VHF, high frequency radio beacons that are near airports. In between airports, there's what they call en route air traffic control, so that the aircraft are commercial aircraft are constantly monitored as they travel from one airport to another. GPS initially had a difficulty providing precise altitude information, and you need altitude to be very precise if you're going to land in zero visibility, obviously. Even a couple of meters would be critical. So the FAA, when they recognized the value of the system, they implemented something called Wide Area Augmentation System. This is an acronym, which I guess a little bit confusing, but it basically consists of a supplemental satellite in geostationary orbit that gives you better altitude information so that you can land in poor visibility. And not only that, but the Europeans and the Japanese have put up their own version of the same kind of satellite. So we have this capability of providing all-weather operations of aircraft very safely. And the FAA, although initially was saying, well, you know, we've got all these other systems that work fine, we don't need GPS, but I think they came around very quickly to realize its value.
Lily, who is watching from New Jersey, wants to know if Uber can transport pets this way.
I'm sure there will be opportunities to do this.
Okay. We have a lot of people watching from Medford, Oregon, Alpha, New Jersey, New Orleans, Chicago, Winchester, Columbia, Maryland, King George, Little Rock, Arkansas, Clarksville, Tennessee, and North Carolina. These new aircraft that you will be using, they're going to be flying around in cities. How important is controlling noise for these?
We consider controlling noise to be absolutely critical to getting customer acceptance and an operation that is actually really friendly to the communities that are out there. I mean, one of the reasons, of course, helicopters are not that popular is because they are very noisy. So we consider these aircraft to be a lot quieter even during takeoff and landing than helicopters, and then when they're en route and flying on the wing with electric motors, you will really barely hear them. They will kind of totally blend into the background noise. But it is certainly one of the key aspects in making sure and that the operations are acceptable. And it's also a criterion on where to place the skyports. For example, you don't necessarily want to have a even somewhat noisy skyport in a very quiet residential neighborhood. That would upset it quite a bit. So those are all concerns when we think about where do we want to take off and land and where do we want to fly across the communities.
And will each of these skyports have their own sort of air traffic control system?
Probably not individually. I mean, they will control the operations that are on the ground and maybe before the aircraft is taking off, just like airports today, they have a set of folks that control the ground operations, and then when you take off in the air, you're kind of being controlled by the air traffic control system. In our case, we are actually relatively convinced, because of the scale of operations that we want to go to. We're going to have to go a little beyond what the voice control, air traffic control is today, and probably kind of work a little off what we've learned already with small drones in how we might be able to control urban aviation slightly differently through more automated means and more information exchange between the different parties, because otherwise we were a little concerned you wouldn't be able to scale it to the amount of operations that we're looking for.
Somebody just got on and would like, again, Paul, if you could give us the quick definition of GPS and maybe tell us a little bit how it works even for farming now these days.
Well, one analogy I've used is if you see a lightning strike a distant object and you count the number of seconds until you hear the thunder, you can get a sense of how far away the lightning is from you. And I guess GPS, it has a very precise clock on board, which sends you the time. But because the time, it takes the speed of light, 186,000 miles per second, to get to you, there is a slight delay. So when you count the delay of the time of that signal to when you receive it, you know how far that satellite is. The satellite's location is precisely determined by the U.S. Air Force from a control station in Colorado Springs. So you have a position, you have the time, and you can, if you have three or four, actually four satellites, you can find out exactly where you are. So that's sort of the simplest way to explain it. It's a little more complicated than that, but basically we know where the satellites are. We know exactly what time they're broadcasting, and we just measure the delay that it takes for that signal to get to your receiver, and that's how you do the calculation. It's a relatively straightforward calculation of time and distance, although things do get a little more complicated, as you might imagine. As I mentioned, there's 24 satellites in 6 orbital planes. They're inclined about 55 degrees to the equator. They are at a medium Earth orbit in a 12-hour period. So they're about 11,000 miles up. And they cover the whole globe, although the polar regions are a little tough, but there are not too many people up there, or down there. But it does work, but it does have global coverage. And I also want to mention the time. The time is also very important. It has a lot of commercial uses and military uses. Your cell phones, for example, rely on the timing to hand off signals and things like that.
So we have some questions coming in about environmental impact. Greg, who is 12, wants to know about the impact. Will it be an improvement over car emissions? And has there been any studies done on the impact of avian life?
So I cannot answer the second question. Actually, I don't know the answer for it. For the first question, there should be a clear improvement over car emissions, at least non-electric cars, because we've tried to make it clear right from the beginning that this for us is only a meaningful service if it's all electric and the aircraft are all electric. And so as you go all electric with more renewable energies, you can significantly reduce your carbon footprint versus car emissions.
And how far will these fly? I'm assuming that you're going to think of them more as taxis than long distance flights.
Correct. So we are looking at ranges of about up to 60 miles. with an average probably maybe around 25 to 30 miles. This is in many of the metropolitan areas or the cities, that's kind of the range where you have the most congestion and where you can save the most time if you fly that far. And also, of course, we're limited by the battery range.
Chloe, who thinks this is cool, by the way, wants to know what might the estimated start date of these be?
So we are currently working towards launching in 2023, probably by the end of 2023, in Dallas and Los Angeles and potentially Melbourne, Australia. So this is where our current launch targets are, and we'll expand then later on from there.
Okay, Ethan would like to know, he is 14 and wants to know, what would the emergency backup systems be if one of these started to fail?
So there's a number of safety, again, as I said before, there's a number of safety layers built in. First of all, different to like helicopters, these have multiple electronic rotors. So usually they might have 6 to 8 rotors, and if one fails, they can actually still fly quite well because there's redundancy built into those rotors. Also, if they fly on a wing, they have opportunities to glide like a winged aircraft. And when you think about it, if you can hover, you don't need much space on the ground. So you can essentially have a lot of additional landing spots, not just like today where you need to have runways, but let's say parking lot of a football station that's empty can be a perfect landing spot for one of these vehicles. So there's a number of fail-safes built in, like if the vehicle really has a system failure, but we're also, of course, thinking a lot about contingencies. If, for example, the skyport is closed, and then how do we divert them to other places? So that is very much built in from the very beginning as we're making the safety case and as we're thinking through all the things that could potentially go wrong and how we mitigate them.
Paul, what do you think, what sort of infrastructure do you see from a historical point would be needed to have all of these different things between airplanes and drones and essentially personal helicopters?
Well, one of the interesting things about GPS was designed right from the beginning, that it is a passive system in the sense that the receivers do not need to transmit any information or interact in any kind of way. I use the comparison with an old-fashioned AM radio. If you have a radio station broadcasting in a city, you can have just about any number of people can tune in. It doesn't matter. If you have something like Spotify, though, it's quite different. If everybody wants to listen to the same song at the same time, the Spotify people have to boost their output. Well, GPS doesn't have that issue. GPS is more like an old-fashioned radio. It can handle lots of, not an infinite number of receivers, but a lot of receivers. Now, having said that, for something like Uber Elevate, there are a lot of other systems that need to be in place that will require power and radio frequencies. So it's not completely that you could have an infinite number of these devices flying around. You have to have other bandwidth that has to be accounted for. You have to have all the kinds of issues about, for example, modern commercial aircraft has a lot of radios on board. So I'd say it's not infinite, but the good news is that GPS was designed right from the start, and that was for a military reason. You didn't want soldiers to broadcast their position when they were trying to find out where they were.
Okay, we have a lot of people watching. We have people from Terre Haute, Indiana, Vincenttown, New Jersey, Spartanburg, South Carolina, Kaiser, Oregon, Chambersburg, Pennsylvania. Please keep those questions coming in. We have Sadie would like to know if the data collected from Uber car rides will help with Uber Elevate.
Oh, that's an interesting question. And it's actually, yes, they do, because Uber car rides tell us how people move around cities. right? We have lots of data for many cities on from where to where people want to go, at which time they want to go, how long it takes them, those types of things. So we can use this data as a starting point to identify what are the biggest choke points, where are the most congested areas where we could actually, like if we were to make a multimodal trip, like I described before, where you have a first leg with a car or scooter, then an aircraft leg, and then you connect them to a different means of transportation. Can we overall save enough time that it's worthwhile doing this versus just doing the regular trip? And at least for the current data, Uber Air, not Uber Air, the regular Uber data gives us a lot of information about how people move around cities already.
And we also have another question. I think this is pretty interesting. Will these aircrafts be piloted or will they be self-driving?
They will be piloted initially. So we're thinking one pilot plus 4 passengers in general will be the size. And we will also initially operate primarily in visual flight conditions. So when the weather is a little bit better, so that the pilots can also operate under the respective rules, which allows them to fly a little bit closer because they can see the other aircraft and they can avoid other aircraft if necessary.
Let's see. Will these types of plans, are you also envisioning them for rural areas?
They can certainly could be used for rural areas if the flight distances that they need to fly are not very long. Otherwise, you might want to go more to like a hybrid model or something, so a hybrid engine that gives you a much larger range than a purely electric version. For Ubers and the way that we operate, we're really interested in bringing this to a certain scale so that we can also get the prices down, make this affordable and the means for everybody. And we kind of see that this larger demand more within the cities and not so much in the rural areas. But that doesn't mean that other folks couldn't use the aircraft in a different version also to serve rural areas as well. But that's not going to be our primary starting point.
Okay. Paul, this is a question I think for both of you. Somebody wanted to know, how easy is it to spoof a GPS signal, to hack into a GPS signal?
Well, the signals themselves are quite low power, and in fact, they're deliberately designed that way. They use a technique called spread spectrum, very low power. But spoofing is something that is a very serious issue, and it has occurred. And the Defense Department, the committee that oversees the management of GPS, is very much aware of it, and they have developed a number of techniques using specialized codes, for example, specialized filters that filter out the noise, the spoofing from the legitimate signal. So it's something that I like to say that it's a known problem. The worst problems you have are the ones where you don't know you have a problem. In this case, we know we have a problem, and we know techniques to deal with it. And thus far, we have been doing very successfully dealing with the spoofing issue. And I assume that we will just continue. It's almost like a cat and mouse game, that we will continue working on techniques. There are a number of other techniques. One of the ones that I always mention was a revival of an older technique called inertial navigation, which is completely immune to spoofing. It fell out of favor for a while, but now it's coming back for that very reason, as a backup in case the GPS has some problems.
And the second part of that question is, would Uber Elevate have fail-safes to make sure that wouldn't happen?
Most certainly. And like Paul said, I mean, this is one of the things that's definitely being brought up, to have inertial navigation systems, for example, on the vehicles to back up the GPS. These flights are relatively short also compared to other flights, so that is a good means. There's also some other ways of providing backup that are more independent, like visual systems that you can use. But most certainly there needs to be a set of fail-safes that actually need to be built into the aircraft right from the get-go to meet the certification standards that the FAA will impose on them.
Also, how will these be different than other helicopters that already exist?
Again, the main thing is these are all electric. These are multi-rotor, and they're utilizing something that's called distributed electric propulsion that Mark Moore, a colleague at Uber and who was at NASA before, has been kind of pioneered a lot. And that allows you to spin all these rotors very independently of each other, and you don't rely on one single big rotor. Also, being all electric, you don't have to have big gearboxes, so the maintenance is going to be a lot simpler. And they're overall going to be quite a bit safer than the current helicopter, and at least as important, a lot quieter than they are today.
I would just like to mention that if you get a chance to visit the museum when it opens, that if you look at a helicopter, a traditional helicopter blade, it's incredibly mechanically complex. It has a lot of hinges and mechanical things that move its pitch and everything. And I think these new designs eliminate all of that, most of that complexity.
With some of these ground-based technologies and this new Uber Elevate, do you think that mass air travel as we see it will become obsolete?
Absolutely not. Because I mean, we're just actually we might be connecting people even better to the airports or to the rest of the air travel. This is a very, very different market. I mean, this is to get you better around within cities to hopefully eventually relieve congestion on the streets within the cities and improve life there. But I think it's not in any way competing with the larger air travel that we see today that goes further distances.
And someone would like to know what kind of pilot's license they would have to get if they want to work for Uber Elevate.
Well, initially, we certainly expect that our pilots will also have to get a commercial pilot license with the minimum number of hours that the FAA will prescribe. Probably helicopter pilots, maybe even more experienced than pilots today, because as these aircraft are new, we want to have very experienced, very safe pilots flying those. But along the way, we hope that these vehicles will actually be much simpler to fly than helicopters, and it's more about making good decisions as a pilot and then getting these flying skills. So there might be a different way of doing the training for these folks to train them for these particular tasks, and the slightly new way that will still require a good amount of expertise, but can be probably done a lot more computer based and in different ways.
And this is just an aside. Elise, who is 8, wants to know if we have cats. I have 2. I know, Tom, you at least have 1.
I don't have any. Sorry.
You don't have any. Do you have any
No.
pets at home, Paul?
No, not really. Sorry.
This seems to be a question
Yes,
that
of
we
course.
get a lot while we're working at
Yes,
home.
yeah.
2 cats and a dog.
You have a cat and a dog. Let's see. What cities has Uber identified to start testing with this new technology?
So for our Uber Air, we've announced Dallas, Texas, Los Angeles, California, and Melbourne, Australia. And we've been operating to learn a lot of these things, a service called Uber Copter in New York City between Manhattan and JFK Airport for over the last half of last year, where we're starting to learn a lot of the things about integrating into this multimodal trip. So this is a service where you already can, from downtown Manhattan, push a button on the Uber app and get the whole multimodal trip, including a helicopter flight to the airport. So this is for testing of some of these systems around it.
So we're quickly coming up on time, so I'm going to end with this question, and I'll start with you, Tom, and then I'm going to rephrase it for Paul a little bit. Tom, do you see self-driving cars taking you to these airplanes?
Potentially, yes. They're part of our ride-sharing plans as well. Yes.
Paul, what does it take to make a self-driving car safe?
Well, they already have a lot of systems in current automobiles that have small radar transmitters on the bumpers, and they have obviously GPS, and they have other networking ability to network with other cars on the road to prevent collisions and to maintain safe speeds. So a lot of the infrastructure is already being put into place. There are a lot of complex things that have to be done, but I think we're moving very rapidly toward that time. There are still some things to be worked out, obviously, and I'd be the first to say that, but I think we're getting very, very close to having self-driving cars. Absolutely.
I personally cannot wait for a self-driving car. I do not like to drive, particularly in Washington, D.C., although I imagine it's easier these days. I want to thank you both for joining us today and answering all these questions. And thank you, those of you who are watching. And I also want to shout out to Boeing, who has been sponsoring these What's New in Aerospace. Thank you so much for watching. And gentlemen, thanks for joining us.
You're very welcome.
Thanks very much for having me.
Sure.